let me switch to English. Okay, this is one of the two sessions that we will take in English. That means that this kind of events is not only local events. In fact, we had a lot of proposals, sessions for people that coming from other countries. So it's a pride for us to get this kind of proposal, and one of them has chosen to these events. So I would like to thank you, Nick, for coming from UK, I think. And I think that he will introduce himself better than me, but the next section will talk about the identity and access management. That I think that this is a very, very important domain, a very complex domain. So it's your time, Nick. Thank you for coming.
Thank you. Thank you. So, hi everyone. Oh, maybe it's a bit loud. He's speaking very loud, so here? Yeah. So first of all, thank you for having me. It's my first time in this part of Spain, and apparently it's not tapas here, it's like pinchos? Yeah, which is a lot bigger. So for me as a runner, I eat a lot, so the bigger the part, the better. So hopefully your English is better than my Spanish. Yes. So I know sometimes it can be a bit, people can be shy if it's not their native language. So what we're going to do is there will be a QR code here that you can scan. You can ask any questions. If we've got spare time at the end, I will answer them. Just scan it. If you have any question, put them here. It will appear for me at the end. Sorry, it's you. So yeah, today we're going to follow the journey of an application. It's a modern microservices-based application in EKS, and what kind of security patterns we should apply to it. We'll go through the pain on what you have to configure, and also how we can alleviate this by using an open source project called Authorize, like Otter. So this is the theme of our company, Otter. So you will see some reference to this nice animal. And so I know we had a little break with some food, but don't sleep. There will be a quiz at the end with some swag to win for only the first three, the three winners, let's call it this way. All right. So half an hour, we'll go to a demo. I will try to go a bit faster on the slide part so we can focus on the demo and the live part. So I want to hide it. Everyone could scan that? Yeah? Cool. Yeah, so let's get going. So my name is Nick. I live in the UK, but I'm French. Maybe you can pick up my accent. So yeah, I got a good taste for good food. So you can imagine that in the UK it's not great, but I've been living there for 12 years. I've been living in Silicon Valley as well, working for big companies, small startup, for probably around 7-8 years now on Kubernetes, focusing on engineering for CNI, so networking, CSI, storage, edge security. But just so that I can understand my audience, so who knows Kubernetes here? Okay, probably half, 50%. Who is a developer? A couple of you guys. Security? Oh, it's always, like a couple of security people, like the party poopers, Platform engineering, DevOps. Okay, so it's probably the same sort of people who knows Kubernetes. So I'll try to go, to set the level in terms of Kubernetes and knowledge for everyone, so that everyone can sort of understand the whole process of, dealing with this application. So I enjoyed coding fun applications. You're going to see it's a Goldberg machine, or Rube Goldberg machine, is it? Yeah, like a super over-engineered sort of microservices. We're going to see in a minute, but it's going to be fun. I'm the head of developer relation at Authorize, cybersecurity company based in Israel. I love to run a lot, and actually tomorrow I'm going to be running about 25K around in Gijón, so it's my first time here. Hopefully I'm going to discover a lot of hills. I think it's quite hilly here. And yeah, you can add me on LinkedIn, Twitter. I mean, I don't use really Twitter nowadays. Yeah, it's been weird, a lot of bots nowadays. And of course, my preferred social network is Strava, like any runner. Okay. So just want to introduce Authorize. So Authorize has been created with the cloud adoption, we've seen a lot of security kind of problematics where it's kind of pushed with the DevOps principle. You push down as many things as you can to the developers, including security. But the problem with security is that now as a developer, if you develop modern application, you have to learn a lot of different languages, a lot of different domain-specific language, whether it's security for IAM in AWS, you can have GCP, Azure, network policies in Kubernetes, you may have to know how to create access lists for Kafka, all these kind of things. But for them, it's kind of overwhelming. So the idea here for Authorize is to find a common abstraction so that as a developer or as a platform admin, you can address the distinct and disjoint security domains by using a single resource. And that's going to be a Kubernetes resource. So who is familiar with the operator model in Kubernetes and a custom resource? Okay, so very quickly for people who don't know what that is. So Kubernetes is great at running modern application, but also it's great as an automation engine. So meaning that by default, the behavior of Kubernetes is to reconcile a desired state with what is really running into your cluster. So it's valid for application, but also think about Terraform, right? If you want to deploy an EC2 instance, you have a Terraform script with a specific language. Well, if you have Kubernetes, you can easily write, actually HashiCorp already has that, a Terraform operator that will just, you push the script, but once you add it you push it to Kubernetes, the Terraform operator will reconcile your infrastructure with what you want. So it's like applying the Terraform script into your environment, but instead of having a complex HCL language, you use only YAML. So it's a lot simpler, and also it's streamlined the whole process, because it's regardless of what you want to do, whether it's AWS or you want to write a custom operator, you can just extend the Kubernetes API by creating your own objects, and the operator, which will be the automation that will reconcile this YAML file with what you really want to do. And this is what we are doing with Authorize. So we're going to see this in the demo, right? So this is the application. It's a fun one. So it's a dad jokes generator, which are not really fun, but yeah, it's for education. So the idea here is to generate a joke from the OpenAI API using the chat completion API, storing it into DynamoDB in AWS, also caching it into Redis. And the way it works is we have a joke server where we request the joke, and it's publishing the jobs to a NATS queuing system. It's like Kafka, a message bus, and then the joke worker is going to pick up that message, request it from OpenAI, store it in DynamoDB as well as in Redis. So I told you it's kind of over-engineered, but that's the principle. So if we look at that, we're going to see that we have to deal with different security mechanism, but right now it's not secure. So the first thing we want to do is, how can we generate this DynamoDB here using Kubernetes as opposed to using Terraform? Well, there is a thing that is called ACK, which stands for AWS Controller for Kubernetes. So who is familiar with that? 2, 3, 4, a couple of people. So the idea of that is, instead of using CloudFormation or Terraform, you can make any AWS resource first-class citizen into Kubernetes. So what that means is, for developers, you can consume add-on services required by Kubernetes application, meaning like you run application in Kubernetes, but you want some serverless component in AWS, or maybe like DynamoDB, RDS, or whatever service. So you can define and automate the creation and the whole life cycle of those resources just using Kubernetes and YAML. So for devs, it's very useful because they don't have to deal with the extra complexity of Terraform or any infrastructure as code workflows. And for platform teams, well, it replaces traditional IRSA workflow, again, with simple YAML definition, and leverage Kubernetes API for reconciliation. So if you know Kubernetes and if you know YAML, you can very easily do that. So here, hopefully it's big enough. This is how it runs in Kubernetes. So you have your EKS cluster. You install the ACK controller here in its dedicated namespace, collocated with your application. So what that means is that now you're using Kubernetes both as a control plane to run the automation, but also as a data plane to run your mission critical application if you wish so. So, oops. What you do here is, now this is how you create a DynamoDB table. Can I do that? Oh yeah, nice. I love Mac. So here you can see the typical attributes you would set for DynamoDB. So the attribute name, joke, the attribute type, billing mode, the key schema, the table class, standard, and the table name, right? So if you create this very simple resource, push this to Kubernetes with kubectl apply, then it's going to create that DynamoDB within AWS, right? So this is an example with DynamoDB, but it's pretty much any sort of resource. You just have to install the right controller for that. So very easy. If you do kubectl delete, then it's going to delete that resource in the cluster, and the operator that is monitoring what you do in the cluster, as a result, is going to delete the resource in AWS. If you want to update it, you can do kubectl edit, change some of the parameters there, and dynamically it's going to be changed into AWS. You don't have any sort of state to maintain. Everything is running into your Kubernetes cluster as a first-class citizen. So Kubernetes understands now, because you've installed that controller, what a DynamoDB table is, right? So you can do the same with EC2 instances or any service. All right. So now, the complex part, right? IRSA. So IAM role for service accounts. Who is familiar with that? Yeah, it's really a pain, isn't it? So now we also have pod identity, but that will be for another talk. So the idea of IAM roles for service account is to give the ability to map service accounts in Kubernetes. So what is a service account? Is a non-human identity that can access the API server, right? So what that means is if you have a service account, you can associate permissions via cluster role and cluster role binding. You can assign permission for service account to do action in the Kubernetes API. Like in the same way, you would have like a EC2 instance profile that will give you permissions to do things in the AWS API. Kubernetes has the same model where you could do things with the Kubernetes API. Create pods, create application, deployment, all this kind of stuff. So now the second thing is IRSA allows you to replace the shared credential that you use typically in AWS by just-in-time, short-lived, so JSON Web Token or JOT tokens mapping SA to AWS role. So you can say with this particular service account created for that particular pod, so every container is running a service, is attached to a service account. And that service account, you can associate IAM roles in AWS. So then when you run a pod that needs to access or do things in AWS, like our joke worker need to write the joke into the DynamoDB table, then you have to give these permissions to the pod, to the joke worker, therefore to the service account attached to that pod, right? So IRSA is how you do that. Right? So yeah, it's kind of complicated, but the workflow is that, so you associate here a service account to a pod. When the pod is scheduled on the cluster, we have a mutating webhook, which is just like a hook, that's going to tell the API server, so is going to allocate a token to that particular pod, right? Once you reference the IAM role in the service account, so you have your service account, you map manually the service account in Kubernetes with the IAM role in AWS. First step. Then in AWS, you have to configure the OIDC provider for your EKS cluster. You have to manually create the trust policy to say, okay, this service account has the permission to assume a particular role. The first thing, you have to create the permissions policy for DynamoDB. So basically here, every kind of cogwheel is a manual configuration point, right? So you associate the IAM role to the service account. The API server, because it's running in EKS, is gonna give you a token. That token is mounted as a projected volume. Remember, projected volume. Maybe a question on that in the quiz. As a projected volume into the pod. And then when you have your application running, so the joke worker, we have the AWS SDK running. And as you will do action to the database using the SDK will know that it's running, in IRSA environment. And then it's going to send the request to the STS endpoint with web identity to assume the role in AWS. And by the way, STS endpoint by default for service accounts are regional. So maybe remember that as well, it's regional. And as a result, if the token is valid, and if you have the right permissions here, then the AWS is going to send you just-in-time credentials that are not stored anywhere, but that the SDK is aware of. So any actions, like writing the jokes in the table, will be done using those temporary credentials. So you don't have to do anything. Now your typical shared credentials, so key and everything, is just replaced with those temporary credentials, which is obviously a security best practice. Hopefully that makes sense. Okay, but now it's not the only mechanism, right? So we know how to secure the AWS resource, but there are other components. If you think about our application, every kind of green block here is like something you have to punch into like the protection, right? It's like a firewall, and you have to allow for a specific port from a specific source. So the joke server, you have to allow any users to access it, restrict the rest. Then from the joke server to the NATS message queuing, you have to allow joke server to NATS. Same thing, worker is going to pick up the job, so you have to allow NATS. And joke worker needs to write to Redis, so you need to allow that. Is going to write also to the DynamoDB, so you need to allow egress access to a particular set of IPs. You need to allow for STS, and you also need to allow traffic to go to the OpenAI API. And typically, you want to reduce the rest of the communication. You don't want to allow any pod to talk over to the internet, right? You want to reduce that to the minimum for the application to work. Which in Kubernetes, you have to use network policies, but network policies are quite hard to maintain. And yeah, you need to know all these IP addresses corresponding to all the address potentially used by AWS STS service, OpenAI, etc. And then yeah, here you have to manage those different definitions as well in Kubernetes. So it's quite complicated. But again, if we think about Kubernetes and what is done so far for automation and the ability to extend the Kubernetes API the same way the ACK controller is doing it, the authorized open source project is doing the same thing with a resource called client intent, which actually the methodology or the pattern to do that is called IBAC, or intent-based access control. So the idea of that is to have a high-level language regardless of what you want to secure, whether it's network policy, application, Kafka, create database credentials, create all these IAM roles, we want to have the same resource, high level. So the idea here is just the example. If we focus on the joke worker, because it's the guy that needs the most access to create, to make the application work. So let's say now we want to allow joke worker to call NATS. So as easy as that, what we can do is, so the kind is client intents, which is a new resource that we made first-class citizen in Kubernetes, the same way we made DynamoDB first-class citizen. When you install the authorized open source project, then you have a new resource, security resource available that is called client intent. So what we want to do from the service joke worker, we want to call NATS. As easy as that. We don't want to create the network policy. Just by doing this, we're going to automate the creation of the network policies. Now, we've seen that we also need to allow Redis. So we just add a new entry, Redis. Again, it's just YAML. So now for the egress, we want to call out internet services. So domain, we want to call api.openai.com. We want to call the DynamoDB, the specific region. You can add more than one. And we want to also add STS. And the good thing about that is not only you can do it manually, but Authorize can also use, anyone is familiar with eBPF? It's been quite big, yeah? So eBPF gives you access to what's happening in the kernel. So we can actually snoop and monitor an application in terms of what API calls is doing to anywhere. So we can monitor from the joke worker what website, what DNS it's trying to access, what permission it requires, and we can generate that particular file for you. Right? So basically, you can auto-generate that file. You don't necessarily have to do it manually. So we support auto-generated and manual as well. Remember that. Maybe a question in the quiz. Okay, so that's for the internet part. So now how about AWS? But same thing. Now, the only difference is that we're going to specify type is AWS, and then we can specify the ARN of, remember, the jokes table that we have created, and the action would be bad practice here, which is the permissions. Star means basically everything, right? So typically, it didn't go on the screen, but you would, you want to specify the exact permissions, or you can let Authorize decide what are the current calls that you are performing on the DynamoDB API, right? Okay, so now instead of having this whole IRSA complicated process, the only manual configuration you have to do now, instead of configuring the roles and everything, you just have to annotate the pod with create AWS role to true. So for the joke worker, if you do that, Authorize is going to reconcile the desired state, which is basically create, please, an AWS role, and then we will manage all the configuration we've seen so far. So everything here is going to be reconciled using a Kubernetes operator, right? So there's no more manual configuration. All right, so let's move to, what time do I have? Like 10 minutes more, right? Yeah, okay, so we should take time. All right, so this is my Kubernetes cluster. So currently you can see on top, I just have Authorize installed. So Authorize is just 3 operator, credentials operator to create, credentials. The intents operator, which is the part that is translating this high-level client intent into lower-level security domain-specific language like IAM role, network policy, Kafka, internet, all these kind of things. We have the network mapper. Its job is basically to communicate with the different sniffer, and the sniffer are monitoring the application calls so that we can generate the client intent for you, right? And then, the network sniffer is 1 per Kubernetes nodes. So Authorize itself is running in the cluster, but we can automate things, obviously, that are outside of the cluster, like AWS, any cloud, databases, Kafka, all these kind of things. So the first thing I'm going to do, so here I've installed also, you can see the ACK controller, which should be here. So I've got the DynamoDB controller, which install a new custom resource. So if I go for DynamoDB, so here you can see this, I have a table. So that table is now first-class citizen in Kubernetes. So I create an object of type table with the properties I've shown you before. So let's deploy the application. Now, so it's going to deploy my dad jokes application. So hopefully I should see new pod coming. Come on, please. It's always the demo effect. Yeah. When you try 10 times before it works, and suddenly when you do it live, it doesn't, but hopefully it's going to work. It's going to take a couple of seconds. So you can see I've got my joke worker, joke server, the NATs, Redis, everything is there. So let's wait. So crash loopback, because it's basically waiting for the different services to be up and running. In the meantime, let's check in AWS. Here, IAM. I shouldn't have any roles there. We should see for dev, OTR. Oh, it's there already. Okay, so it's deploying. Yeah, I've got the client intent deployed. So now the application is working. I've also deployed the client intent. So the client intent I've deployed are there. Client intent here. Let's deploy them. That's all the client intent. So the client intent for joke server, joke worker. If we take a look at the joke worker, we should see what we have seen before, right? So I have now AWS action, the name of my resource, the type, and same thing for the internet and the calls. So now if I see in the network policies, I should see new network policy as well. So you can see that now, because I have the client intent apply, I've got the different network policy that have been created by Authorize, right? With the labels and everything. You don't have to do this manually. Authorize is doing it for you. So basically now, what I've done, I've secured the whole application, the network policy, and I can also, if I check into AWS, here, loading policy, remember, DynamoDB star, which is bad practice, is there, and also the trust relationship is configured. So that particular service account, so dev, in the namespace dev called default, is a legit service account that can access STS and through the OIDC provider. So you don't have to configure that part manually either. And now if I check the DynamoDB table, so hopefully it should be there. Yeah, the joke table is there. It's because as part of the application, now I should be able to see a table. So now the jokes table has been created with the parameter I've shown you before, like the paper requests, the attribute name, etc., right? So as part of the application deployment, I've simply added this particular resource, so I don't have to have an IAC repository. I can specify this YAML file as part of my pipeline to deploy the application, right? Just YAML, and it's going to be pushed to Kubernetes. So now let's try the application. So if I go back to the pods, oops, come on, pods. Let's try to use the server. So I need to export the port. Okay, let's try to generate some jokes, cross fingers. So let's at the same time monitor the joke worker, logs. Okay, so you can see I don't have any errors, which means that the joke now should be saved in the database because I have the permissions to do so. So now if we check the joke table, hopefully you can see the jokes that are stored in the jokes table because I've given access to the internet to the right API endpoint, and I've given access and permission to write in the right table. Okay. What else? So that's pretty much it. So we've seen the network policies, we've seen the permissions to write into the DynamoDB database, we've seen the internet access. Yeah, so that's pretty much it for the application. And yeah, it's been working so far. That's great. Okay, so now let's go to the quiz. You can go to kahoot.it. It's the same. Yeah, we have about 5 minutes. Yeah, should be fine. Scan this. I'm going to give you a PIN number in 2 seconds. So either scan it or go to www.kahoot.it. Right? And now I just need to start it. So it's going to ask you for an email. So if you want to win, if you really want to put your real email address, I will, not to spam you, I'm going to contact you later to send swag to your home, right? So let's start. So it's going to tell you the PIN normally. Please internet work. Okay, that's the PIN, 538139. Oh, I should click on start, right? No, waiting for players. What, no one is there yet? You can customize your avatar if you want to. So normally it's using the local language to create the nickname, which I won't understand, so. Pato diligente, what does that mean? Pulpo ansioso. What is... Wombat plate... Halcon bonito? Yeah, it's always funny. When I do a different country, sometimes the worst is in Germany because you can do basically a sentence with all the words put together, and then everyone has a nickname with the whole alphabet. Okay, come on. Let's wait a little bit. So there will be 5 questions. You have 20 seconds per question. All right? Let's wait. Some people like my daughter will say, like, you're a slow coach. Okay? Let's 5 more seconds. 5, 4. Oh, 5, 4, 3, 2, 1. Okay, start. So normally, I think I've pretty much everything. You should have all the answer. Okay, so first question. How does the ACK controller keep AWS resources consistent with Kubernetes CRDs? Polling AWS API, reconciliation loop, cache state and sync on schedule, uses webhook for state changes. I mentioned it several times. Okay. Also, there's a notion of speed, so the faster you get the right answer, the better. All right. So that was what? Webhooks? No, reconciliation. The operator model, reconciliation loop. This is how it happens. Okay. So who's leading? Kind Unicorn. Okay. Next one. What Kubernetes resource is used to store the service account token for IRSA to function properly? I've given the answer. Config map, secret, projected volume, or PVC? Oh, player, identifier. Sometimes I forget that, and then it's a mess to contact people. Okay, so of course it was a project. But you guys, what about the other ones? You didn't listen to me. I give you the answer. You guys were sleeping, actually. Okay. So who's Kind Unicorn? Oh, I can feel the winner here. Only 2 questions, but I think this lady or guy is, really wants the swag. So what is required for authorized to automate the full IRSA workflow? So I also mentioned it. Annotate the pod and create a role. Annotate the service account and the pod. Annotate the pod. Annotate the pod and associate an OIDC provider to the cluster. If you don't know, just one answer. Yeah, because it's reducing the number of manual action. Yeah, right. Oh. All right, so who's leading? Kind Unicorn. Oh my God, I think But now, as I said, swag for the first 3 of them, right? Penultimate question. Multi-select, so 2, I think 2. How does authorized guarantee least privilege permissions for IAM role? Making API calls to the Kubernetes API server, inspected API calls to AWS, relying on manual configuration by configuring network load balancer. Remember this eBPF thing, what we can do with that? Yeah. Making API, what? Inspecting API calls to AWS using eBPF. That's the right one. Okay, well, I think Kind Unicorn is, well, but the creative macro is not too far away. Okay, last one, and right on time. So what is the default SES endpoint type for service account? I also mentioned it, zonal, global, universal, regional. Now that's, is Unicorn going to win? All right, so yes, regional. But what about the other? Yeah, you didn't listen. It's crazy. All right, so what about the podium? Drum rolls. So 3. Pato diligente or gente? Gente, diligente. Creative Mako, and I think it's no real suspense. Kind Unicorn. So, all right, great. So a couple of other resources for you guys. I mean, you can take a picture. Where am I now? Here, if you want, just take a picture. If you want to learn more, oh, there's no questions. Oh yeah, of course, if you didn't listen, you can ask questions. So take a picture. If you want to learn more about Authorize, we do have like hands-on labs. You can join the community Slack if you want to ask me questions or just talk to me because I'm a cool guy, you know. And then we also have, I've written an article about this particular dad jokes application, explaining what I've explained today, but in more depth, right? That's pretty much it for me. So thank you very much, and hopefully that was fun. Thank you.